We continue with probability. Question number 16. 12 defective pens are accidentally mixed with 132 good ones. It is not possible to look at a pen and tell whether or not it is defective. One pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. So let's find the total number of outcome. Formula we'll get from the total number of pens, right? Both the defective and the good pens together, how much do we get? Total number of outcome to be 144. Now the question told us determine the probability that the pen taken out is a good one. So my favorable outcome will be number of good pens. How many are there? There are 132, right? So now the probability that we'll get a good pen, favorable outcome divided total number outcome. Favorable outcome is how much? 132. Then total number outcome is 144, right? Which you can divide further and get 11 by 12. Question number 17. A lot of 20 bulbs, right? Total contains 4 defective ones. That means there are 20 bulbs in total, right? 4 are defective. That means how many are good bulbs? 16 good bulbs are there, right? One bulb is drawn at random from the lot. What is the probability that this bulb is defective? So the first is defective, right? So let's find the total number of outcome from the total number of bulbs. The defective and the good bulbs together, how many bulbs? There are 20, which will be the total number of outcome. The favorable outcome, because remember the first is what is the probability that this bulb is defective, right? So number of defective bulbs, how many are there? There are 4. So that will be my favorable outcome. So probability that we'll get a defective bulb, favorable outcome by total number of outcome 4 by 20, which you can divide further and get 1 by 5. Now look at 2, right? Suppose the bulb drawn in 1 is not defective, right? That means good bulb, right? And it's not replaced. So like I told you, there are 16 good bulbs, right? It's not defective, 16 good bulbs, and it's not replaced. That means when I picked up the good one, I've taken out 1, right? And remember, the one good bulb that we have taken out from here is not replaced. Alright, that means I put it aside. So how many good bulbs do I have now? 15 good bulbs. And what is my total number outcome now? It was supposed to be 20, but because I took out 1, now my total number outcome is just 19. Alright, so you can see here the total number outcome will come from the total number of bulbs, 19, right? Because remember there were 20, but I took out 1 good bulb and I have not put it back, right? It has been taken aside, so 19. The favorable outcome is how much? They say what is the probability that this bulb is not defective again? Okay, it's not defective. Then the number of good bulbs, remember there were 16 good bulbs, but I have taken out 1 bulb and I have kept it aside, right? I did not put it back into the lot. That means I only have now 15 good bulbs, right? So once again, probability that we'll get a good bulb, favorable outcome, a total outcome 15 by 19. 18. A box contains 90 discs which are numbered from 1 to 90. If one disc is drawn at random, find the probability that it bears, let's do one after the other, right? A good digit number, a 2-digit number. Then the total number of outcome, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it goes on, right, till 90, because remember the discs are numbered from 1 to 90, which means my total number of outcome will be 90. First was a 2-digit number, right? So from this 1 to 90, the 2-digit number starts from 10, right? 10, 11, 12, 13, 14, 15 goes till 90. So how many are there? How do you find this? 90 minus 9, I'll get 81. Why? Because 1 till 9 are all 1-digit number, right? So from there I'll get my favorable outcome. So probably they will get a 2-digit number, favorable outcome by total number outcome. How many? What is my favorable outcome? 81, right? Total number outcome is 90, which you can divide further and get 9 by 10. A perfect square. So 1 is a square of itself, 4 is a square root of 2, 9 is a square root of 3, 16 is a square root of 4, 25 is a square root of 5, right? 36 is 6 squared, and this is 7 squared, this is 8 squared, 9 squared. So perfect square of my favorable outcome, if you count, will have 9, right? So probably they will get a perfect square favorable outcome divided by total number outcome, 9 by 90, which you can divide further and get 1 by 10. Next, a number divisible by 5. So pretty simple, right? 5, 10, 15, 20. These are all divisible by 5. So how many favorable outcome do I have? If you count them all, it will be 18. Alright, so probability that we'll get a number divisible by 5. Favorable outcome divided by total number of outcome. Favorable outcome is how much? 18. Total number of outcome is 90. Which, when dividing further, we'll get 1 by 5. Alright, question number 19. A child has a die whose 6 faces show the letters given below. Alphabets, right? A, B, instead of numbers, right? This is alphabets A, B, C, D, E, and A. the die is thrown once, what is the probability of getting A and D? So let's first find the total number of outcome. From what we'll get it from the alphabet on the die, right? There's 6, 1, 2, 3, 4, 5, and 6. Clear? So that's my total number of outcome. Now the first part is getting A, right? So how many A's are there? If you look, there are 2, right? One is here and one is here. That means my favorable outcome of getting A is 2. So probability will get A, favorable outcome, divide total number of outcome, 2 by 6, which you can divide further and get 1 by 3. Next is D, right? But if you look here, there's just one D. That means my favorable outcome is just 1. Then probability will get a D, favorable outcome, divide total number of outcomes, 1 by 6. Question number 20. So, alright. Suppose you drop a die, right, at random on the rectangular region. What is the probability that it will land inside the circle of diameter 1? The diameter has been given to us 1, okay? So how do you do this? So they've already given us the dimension, length is 3, and then breadth is 2 meter, okay? 2 meter. That means my total outcome will be the area of this rectangle, right? Length into breadth. So you can see here written, total outcome will be area of rectangle, length into breadth, which is going to be 6 meter. Now my favorite outcome, remember, it's only supposed to land inside the circle. Alright, it's supposed to, the die is supposed to only land here. This becomes my favorable outcome, right? So area of the circle, what is the formula? Pi r square. So they've given us the diameter is 1 meter, right? That means radius will be 1 by 2 meter. Now pi, you just leave it, then r square, because I have to r square means r 2 times, right? 1 by 2 into 1 by 2. So if I multiply, it's going to give me 1 by 4. So pi will just leave it like that, okay? So I'll get here pi by 4. Now probability it will land inside a circle, favorable outcome divided total number of outcome. Favorable outcome is how much? Pi by 4, right? So I've written here pi by 4. Then my total number of outcome is how much? 6. The entire area of this rectangle is 6, which is multiplying 2 4 6, you should get 24. Or my probability to land on the circle is pi by 24.